Good morning, everybody. Welcome. It is 8:15. Our host is Rumbi. She's in the background doing administrative stuff. Morning, Rumbi.
Thank you. Morning.
I'm Tiens. I'm going to be your host for the next 2 days. So I'm going to get going with the slideshow presentation. If you want to check your microphone now, it's fine. You can do that, but you will have opportunity to speak just now as well. So let's get going. This is a course on road construction, maintenance, rehabilitation. We're covering a lot of work in 2 days. So it's going to be a lot of information that's going to be shared. And hopefully you're going to learn quite a lot over the next 2 days. It's easy. So just a quick introduction into myself. As I said, my name is Tian Seeloff. It's also on the screen. I studied civil engineering at University of Johannesburg, got my degree and started working as a contractor, as a site agent in a construction company called Robex for about 4 years, building roads. And then I joined a very small construction company called Petula Construction, where I was director shareholder, mainly building roads for about 10 years. And then in 2007, I left them and I created my own little business. And that's why I'm currently still at construction consultant. I'm a consultant in the construction industry. I give advice. I'm not a consulting engineer. I'm not one of those guys that draws pictures and criticize contractors. Not that guy. You have a problem, you contact me and I give you advice. That's what I do. Okay. Since 2009, I've been doing training, more than 570 courses that I've done, more than 9,500 people that I've trained. So yeah, that's me. Training face-to-face, we've covered the country. Face-to-face, we covered about 13 or so countries. Online, we've done a hell of a lot more. Online, we've covered one planet so far. Good stuff. Let's start with roads. So the whole idea of a road, I've got point A and I've got point B. A road is something between 2 points on Earth. It's a pathway, a roadway, a way amongst two different points. Now, when it comes to roads, we've got a few types of roads. Of these types of roads, the most common or easiest road to create is something that we call a dirt road. A dirt road is a road where I travel from point A to B, and with me traveling up and down, after a while, there's a road. Some people call it a jeep track. Okay, but it's not really, there's a landy over there, so it's not really a jeep. So how is it created? I'm going to start talking about the design principles. So this is where we start learning from this specific minute, the design principles of a road. I'm living in village over here, and there's a village over there. The girls in this village don't like me anymore, so I start visiting the girls in the next village. I've got an old Land Rover. Now, when it comes to me going to that village over there, I just start driving. And as I start driving, this road is created because I keep on the same pathway. Now, two design principles come into play. Firstly, how strong is the earth to carry a load? How strong is it? Can it carry a load? So when it comes to the design of a road, that's one of the things that I will have to figure out in the beginning before I design a road. How strong is the earth? It is majorly important because if the earth is not strong enough to carry a load, then I've got to do something about that. Another thing is, how heavy is the traffic? The earth could be strong to carry pedestrian, but it's maybe not strong enough to carry a guy with a jeep. So you've got to go look at two design principles. How strong is the earth? How heavy is the traffic? Now, if I start visiting the villages around me, after a while, because I've visited too many villages, I've got 7 different wives, I've got lots of children. Suddenly I have to buy cars for all the wives. Now there's 7 cars coming up and down. There's a bus full of children coming up and down. That's the third principle that comes into my design. How strong is the earth, first principle, to carry a load? How capable is it to carry a load? Is it going to collapse? Is it going to fall apart? How heavy is the stuff that's driving on there? Third principle, how heavy and how many stuff will be driving in the future on this road. So whenever I design a road, those are the first principles I have to look at. when I design construction, when I design maintenance, or when I design rehabilitation. They're all the same principles that will be followed. Now, whenever an earth is not strong enough to carry load, I've got to bring something into that earth to make it strong. I can bring anything to make that earth strong. I can bring wood, I can bring glass, I can bring rock, I can bring concrete, I can bring rubber, I can bring plastic. But one of the things that we bring in most of the times to make this earth strong is gravel. Because then we get bases. We spoke about the pavement layers, we spoke about stabilization of pavement layers, especially my subbase. Then we get a base. Now, when we build the base, there's various bases. You can have a G1, G2, G3. Those are the crushed bases. A lot of people will talk about crusher. Then you get G4 and G5, which can also be bases, but not that common, but that's for the lower level traffic. And you can obviously have your base also being CTB or BTB or ETB or BSM. So there's many different options of these different bases. But a very common base is a crushed stone base, especially if you've got very heavy traffic, like G1. G1 is a very common base because it is an amazingly strong base. Now, I'm going to talk today still a lot about where can we employ small contractors, where can we do small community development projects, where can we do all sorts of cool stuff. G1 base is not where I use community. G1 base is not where I use a small contractor. I can use the community to do brooms and sweeping and stuff like that, but it is a skilled thing. It's something for someone with a huge amount of experience. In road construction, the most difficult part of any road construction is G1 base. It is extremely complex. It's extremely difficult to achieve what is supposed to be achieved. They say when you are finished with that G1 base, it's supposed to look like a marble slab, like a kitchen top, granite top. The stones must be in a mosaic pattern. And you will see most bases looks like this, not even close to what it should be looking like. Not even close. So very few people actually have their bases as good as it should be. So it's extremely difficult to get there. How do I build this base? Now, how do I build this base is extremely important because I am going to explain the process now from the start to the beginning. And it's important because of a few things that I'm going to explain afterwards. So add to the bitumen this rubber, which makes it cool. Why? Because bitumen is a lot like a piece of wire. If you take a piece of wire, this is a piece of wire, and you do this to a piece of wire, after a while you will see this piece of wire gets hot and it breaks. Now, when it comes to bitumen, same thing happens to bitumen. Cars are stopping and going, stopping and going, stopping and going, stopping and going. Or the temperature changes, hot, cold, hot, cold, hot, cold. And as this bitumen gets hot, cold, or the cars are stopping and going, it breaks. And that's a problem. Or maybe I am going to have a road, and on top of my road, I'm going to have some bitumen surface. So I've got gravel layers, and on top of these gravel layers, I've got a bitumen surface. But remember, here in Africa, our surfaces are very thin because of money. Because the surface is so thin, when a car drives on top of the surface, that load of that car is immediately going through to the pavement layers. So we've got a huge amount of load. Remember, we spoke about this load yesterday in detail. Because the surface is thin. It's like me putting a piece of paper on a road. If a car drives over the paper does nothing. It just breaks, basically, because it's so thin. Or maybe I want to build a road. I want to maintain a road. So my road is consisting out of various gravel layers. And I've got on my road a very old surface. But this old surface is full of cracks. And I decide for maintenance, I'm going to add onto this old surface a new surface. But over time, those cracks just come through to the top again, reflective cracking. So that's what happened with bitumen. But if I modify my bitumen and I add to my bitumen a bit of rubber, suddenly, when I build my roads with this bitumen, rubber modified bitumen. The cars can stop, go, stop, go, stop, go, stop, go, stop, go. Nothing happens. If I take a piece of wire like this, it breaks. If I take a piece of rubber like this, I get tired. And that's what's amazing about rubber. So if I put it in this surface here over an old surface, those cracks underneath can do this, and this bitumen is just going to do this. So then the cracks does not come to the top. Or because I'm putting a very thin surface on the road, and I'm having traffic on the road, the thin surface does not carry a load. But if I've modified it with rubber, the surface will stretch. It stretches under the traffic, reducing the load in the pavement layers. So it's going to be distributed over a bigger area. So it does load reduction. So it stops reflection from the bottom. It does a load reduction. It helps the surface last longer with stop, go, stop, go, stop, go. With hot, cold, hot, cold, hot, cold. I want to put rubber in my surface. Remember yesterday I said my construction cost plus my maintenance cost gives me my life cycle cost. So obviously if I increase my construction cost by putting rubber, I'm reducing my maintenance cost because I don't have to fix the surface all the time because it doesn't break that easy because it's rubber modified. So rubber is awesome. Rubber is awesome.